Okay, earlier today we did this thing called significant digits. They are a way in which to take a look at a measurement and look at how many actual digits were part of the measurement. Okay? So what we did is we did an example like this one on the board. We had a line we measured. The middle one would be the line. So if you take a look at the top ruler, it's divided into every 10 centimeters you have a line. That gives you an exact measurement. Well, that line is in between 20 and 30. So the 2 is a known digit. It's between 20 and 30 centimeters, and the 8 is the uncertain digit. And then once you do an estimate of an uncertain digit, you need to stop in your measurement. So that first tool will give you 28 centimeters. If you look at the bottom tool, there's more divisions. It's a more accurate ruler. Okay? Gives you more lines of measurement. Gives you every centimeter. So on that one, if you look at it and measure it, we see that it's in between the 7th line, which would be 27 centimeters, and the 8th line between 20 and 30, which is 28 centimeters. So I'm saying that's halfway between, and that is my uncertain digit, and I would stop at the 27.5 centimeters. So that would give you 3 significant digits. Okay? Going back to our definition, significant digits represent the number of measured digits in a measurement. So what it does is it tells you, if you see a number, and we tell you how many significant digits are in that measurement, it tells you how many numbers were actually part of the measurement, and how much. And then later on we'll get into zeros here in a second. So I have 2 stars below that kind of talks about significant digits. So when you write a number that's measured, it represents all certain digits and one uncertain digit. And that uncertain digit is your estimate. Okay? So you always stop at where you're uncertain. There are rules that go with looking at a number that was measured at some point in time. And you're looking at it for the first time, and you didn't measure it. But there's a measurement, and you have to use it in a calculation. So here are 4 rules for you to be successful in determining if a particular measurement and how many significant digits are in that measurement, or how many were measured. So the first one's really easy. Number 1. All non-zero digits are counted as part of the measurement, are counted as significant. Okay, the second one is pretty easy too. There are 4 scenarios with zeros. One scenario is if the zeros are captive. Okay, so when I say captive, what that means is that up here in the upper left, it would be like 7,007. These 2 zeros are significant, so there's 4 significant digits there. Okay, the 4 represents significant digits, without me having to write significant digits behind it each time. Okay, the number 3 has 2 different parts. So we call these zeros trailing zeros, because they're following a non-zero digit. So I call those trailing zeros. So these are 2 examples of trailing zeros. Okay, so what are the 2 scenarios of trailing zeros? Let's say the zeros are following a non-zero digit and we see a decimal. That's what 3a says. 3a says when decimal is shown, when a decimal is shown, it's significant. So scenario 3a would be like the following. These would be 2 examples. 0.700 centimeters. These zeros are significant, so there'd be 3 there. Another scenario would be if I had 70,000, or let's say 70.00. All those zeros are significant behind it because they're trailing a non-zero digit and the decimal is shown. So there would be 4 there in that example. Okay? If we don't have a decimal shown in a number and it's trailing, So if we don't have a number in a certain measurement we see for the first time, and there's no decimal, like 70,000, no decimal, one significant digit. If we have 20 million, one significant digit. If we have 44,000, we have two significant digits. Okay? So if we don't have a decimal and they're trailing, they're always going to be assumed as estimated zeros, and there are non-significant digits. Okay? The last one is with leading zeros. Here's an example I have up here already. So here is leading zeros. They don't count. Leading zeros never count. Okay? So that one has two significant digits. Here's another one with leading zeros. See, this leading zero is not significant. So you can't count it as significant. All right? So here's your assignment that I need you to do. You need to write down these 9 examples. I'm circling the numbers so that it doesn't get mixed up with the actual measurement that's written out. And I've done the first one for you. So on that one I say captive zeros count. So 0.0 in between the 4 and 5, they're captive zeros. So we say that they're 4 significant digits. What I need you to do is do 2 through 9. Do 2 through 9 for that as an example. I can also give you page numbers that are in your book that will help you with this process as well if you want to look in your book for further examples and further explanation. All right? So if you have your book, you would look under where they talk about significant figures on page 32 through 34. Page 32 through 34 also gives you that information, but I'd like you to have that done for tomorrow. After the quiz, we'll go through what you have, but have it done so I can give you a completion grade for that.